Hi, today we're going to do number 1046, vast stone weight. So we have an array of stones and we play a game where we get the two highest ones and we smash them together. So here we have the stones, we got the two highest ones, 7 and 8, smash them, the difference is 1. So we remove the 7, 8 and add the 1. Now we have 2, 4, 1, 1. The next two highs is 4 and 2, so we smash those together. So we get rid of them, 2, and then we add 2. Now we get the next two highs, 2, 1, 1. Delete them, get the difference, and add 1 again. Now 1, 1, smash them, and if there's 0, we don't add anything else. And if there's 1 or less, if there's 1 remaining stone, we return that stone. If it's 0, we return 0. So how can we solve this problem? And the key here is that we need things sorted so we can effectively smash them and get the two highest ones. So we can do a sort way. And here we have to loop through this while stones is longer than 1. We sort it, get the two highs, we remove the two highest ones, we pop the two highs, pop the first two, and then get difference. If difference, add it to the stone. And we have to sort it each time we loop it, because once we get a difference, it could be a high difference and it could change the sorting. And then we return the last stone or 0. So that's one way. Another way data structure we use is a max priority queue. And this way is going to be log n to insert and remove. And here the root of the tree will be the max, so we can just easily decrease or remove the max one at a time. So we do this the same thing, loop through while stones. First we add everything to the queue. Max. And then we don't have to sort it because this will handle the sorting at log n. And then we loop through while max, I'll do it, has size greater than 1. And same idea that we dequeue first 2, get difference. If there is a difference, add it to the queue, and then we return the last stone or queue. I forgot the time space complexity. So for sorting, the time is going to be O of n squared log n, because we're going to loop through this entire time, and for every time we do n log n sorting. And now for the space complexity, since we're using the pre-built sort, we can round down to the lowest one, which would be O of n space. And now for the time complexity for the max priority queue, we're doing O, since we're looping through this entire array, it's going to be O of n times log n. Since log n is what we use to sort, we add it to the max queue. And then the space complexity is going to be O of n, since we're creating this max priority queue for the length of the stones, which is n. So since the max priority queue has a better time complexity, we'll go with that, but I'll show you both ways. So first thing is that we create this max priority queue. So const max queue equals new max priority queue. And then we loop through stones to add to it for a const stone of stones max queue dot eq stone. So now our max queue is filled out. Now we want to do a while loop while max queue has of size greater than 1. We want to get 2 of them out. So const stone 1 equals max queue dot d and q. Not d. There's no n. dq. And then const stone 2 dq again. And now we add it if there's a difference. So if stone 1 minus stone 2 is greater than 0, we add it. So max q dot nq stone 1 minus stone 2. And then we'll go through the process until there's one or less left. So return, depending on if it has a size of 1 or not. If it has 1, we just get the last one, so we just dequeue it. Otherwise, we return 0. Great, so that's one way to solve it, and then I'll show you the other way, which we will short. So we do a while loop, stones dot length is greater than 1. We sort it, so stones dot sort and then we get the difference. So const stone 1 equals stones dot pop, const stone 2 equals stones dot pop. And now we do the same logic as before. If there's a difference, stone 1. So stone 1 is always going to be bigger because it's sorted. Stone 2, that's why we have it first, is greater than 0. We push it. Stones dot push stone 1 minus stone 2. And now we return the same. So return stones dot length equals 1. We return that one. So that first one. Otherwise, we just return 0. Great. So these are 2 ways to solve it. The key here is that we need the list to be in sorted order so we can sort it each time, but that would be taking a lot of time complexity sorting it as we loop through. We can improve it by using a max priority queue. So we will have the maximum at the top, and we can just remove the top as it comes and add things at log n times, and we can get the answer. Thank you so much.